This is just a short video on a method for pick and place for surface mount components. So the board we're looking at is this guy here. It's just a little switching LED thing, and it's laid out in Eagle, but any CAD program will do this. And the part that's important is this table here of all of the components, and we need these XY positions of the parts and their angle. So that's all. I'm pretty sure all programs will do that. Okay, we go to a CAD program and we draw up the parts here. Now, even if the ECAD program has a 3D export, that's not really suitable because these parts need to be slightly bigger than the actual component. You'll see why in a second. So, you'll see why now. Because what we're making here is a sort of negative mold of the part. It's this guy here that's been 3D printed, and you need to make these holes big enough, just turn that around, that the parts will fit in there easily. Now, with my printer, what it works out is that you basically need to make those little components one nozzle width larger in the XY direction and one layer width deeper than what is required. So that's why you can't use just the normal 3D output of your ECAD program. So this is the little mounting aid, and we'll just use it now. Okay, we'll give this a go and get to work here. And the idea is that you put them in the wells one by one. You've got to put them in upside down, which is a bit of a complication, but it's handy. You can just move the mold around. These are 0805 parts, which work pretty well. I think you could do 0603, and that might be about the limit for it, I think. Oops. These tweezers are magnetized, unfortunately. And the biggest problem is the parts are upside down, so you can't really tell with the spot on some parts whether you've got them the right way. You have to be a bit thoughtful about how you do it. That's the principle. And this has not got any solder paste on it today, but at this moment, but what you do is you paste it up. Ta-da, done. So, whoops, the LED didn't come out of there. So that was the first attempt. The main problem is that they're upside down, which makes it a bit awkward. So I made a second refinement to it, which is sort of, I should have mentioned too, pays to print it in a light material so you can annotate it with the parts that you want. And so this is back to the board really, it's the flip again, and the idea is that you can put the parts on here in the correct, not flipped over, so you can see what you're doing. So we'll try that. Modified version, this was the attempt to make it so they're up the right way and you can see what you're doing. To be honest, it has not worked out brilliantly. They've just got these little wells here. So this time you can see exactly where the spot's meant to be. And you can see you've got all the values in the right spot, which is cool. Come on. Where'd that go? Missing a part there. Won't worry about the meantime, but you'll see it actually does not work as brilliantly as I hoped. I was hoping would happen. That would fit on there. You take that off, and you put this guy here, flip it again, and there's the parts. And actually that's worked out pretty well on that occasion. So that would be a go. And then the final modification is this one, which my neighbour suggested actually, and it's sort of just the holes of the previous ones, and it works in a slightly different way. So we are doing the last method now, which is start by putting this, so this is the one with just the holes in it. Yeah. You put your part in there. Oops. And you populate it as before. That's actually meant to be a 1206 capacitor, but we don't care. And 103. So this is quite quick to do, this guy, and of course the parts are all up the right way. And then when you've done all of that, it's just a matter picking it up carefully and select one part behind there. So that's the third method, which I'm going to try now with the solder paste. Good enough. Just going to do this on a little block of wood, it makes it a bit easier. And to work. Job done. And there's the board. So at the end of that, this is the boards that I made. They all seem to have turned out pretty nice. And they've got their through-hole parts to be added in. The holey version of the guide worked the best. I got it down to about 2 minutes to do a board, including putting on the solder paste, so that's not too bad. It takes 5 minutes to reflow them. There's also there's a couple from when I was not using the holes, but this is the first version, so that's just another board there. And you can see you can actually do one for through-hole components as well, which sort of makes quite a handy jig for those. I'll probably modify those and get a bit of rubber foam down in the bottom to just hold those all nice and neat when they're done. So I hope that's useful to somebody, and if you've got any suggestions, always happy to hear them. Ciao.